solves problem involving linear functions. Given a worker in a computer repair shop is being paid a salary of 75 reals per day and 50 reals for every computer that he can fix. Question A, or Task A, write the daily salary of the worker as a function of the number of computers that he can fix. Since this kind of given is a linear function given, we will use y equals mx plus b to represent our function. Okay, so let y is equal to the salary and let x is equal to the number of computer. Why did we use variable y to represent the salary? Since y here is the dependent variable, we know that the salary depends on the number of computer x. So therefore, y is our salary, which is the dependent variable, and x is the independent variable. And our m here, or the slope, that is 50, because that is the rate wherein in every computer that he can fix, there will be additional 50 reals added to his initial salary per day, which is 75 reals. And that 75 reals, that will be our y-intercept. Recall that when we say y-intercept, the value of x is 0. And since our computer here, the number of computer represents the x, let's say there were no computer that were fixed. So it means he can still receive 75 reals. Okay, so replacing these values to our y equals mx plus b. So replacing m by 50 and b by 75, and this is now our modeled function for this given. Okay, for the task B, find the domain and the range of his salary. Assumes that there is no limit to the number of computer to be fixed. Okay, so remember that when we say domain, that is the set of all x values. And our x here is the number of computer. So what is the minimum possible number of computer that he can fix? In this case, that is 0. So we cannot say negative because the lowest number here is 0 because we're talking of the quantity. Okay, so what is the highest possible or the largest possible number of computer that he can fix? That is positive infinity because we will assume here that there is no limit to the number of computer that he can fix. Okay, so for our range, remember that when you say range, that is the set of all y values. And in this case, our y here represents the salary. And what is the minimum number of salary or amount of salary that he can receive? And that is 75 reals if there were no computer fixed on that day. And how much is the maximum amount of salary that he can receive? So it can be positive infinity. So notice that we uses a rectangular bracket and a curly bracket on the right side. So this rectangular bracket says that this 0 is included. Okay. For the question C, if he was able to finish fixing 5 computers in a day, how much salary will he receive for that day? So we are now looking for the salary, and that salary is represented by variable y. So we have a given here, the 5 computers, and this number of computer is our x. So we can set x is equal to 5. Then using this equation, y equals 50x plus 75, we will just replace x by 5. Then solve the equation. 50 times 5, that is 250, added by 75, and that is 325. So for our question, how much salary will he receive for that day? If 5 computers were fixed, he will receive, or the salary he will receive is 325 reals. For our question D, how many computers must he fix to earn 625 reals a day? So this 625 reals a day, that is the salary, which is represented by variable y. Therefore, our y is 625. So using the same function, y equals 50x plus 75. So we can replace the 625 to y. Then we will solve for x. So to isolate x, we will add negative 75 to both sides. So 50x is left here, 625 minus 75, and that is 550. And finally, divide both sides by 50 so that x will be left by itself. So write down x here. 50 is cancelled, then 550 divided by 50, that is 11. So our x here is 11. This x represents the number of computer. Now for our question, how many computers must he fix to earn 625 a day? Our answer is he must fix 11 computers.